So finally the opportunity has come to talk about one of my favorite languages and environments on this show. And this is the Elixir language and the Nerves framework specifically. Nerves is a way to create and maintain applications for embedded computers such as the Raspberry Pi in a particularly easygoing way. Think an Arduino IDE for Raspberry Pi, only supercharged with IoT-centric libraries and tools. We're going to look at how to install all the prerequisites for it and code a simple time-lapse video using the Cloudinary image cloud storage. The hardware I use is a Raspberry Pi Zero with a camera module version 2. Let's jump right in. Before we get to actual coding, we're going to set up a Cloudinary account. We will use Cloudinary's advanced image processing capabilities to transform uploaded images and concatenate them into a time-lapse. I'm going to cloudinary.com and set up an account. This is pretty straightforward, just follow along here and fill in some values. You are assigned an API key and an API secret, which we will need later on. You can always access them on your dashboard. The free plan gives you 25 Cloudinary credits, which is a compound value of your storage and transfer rate in gigabytes, as well as applied transformations. You can read more about that in the documentation. Next, we're going to set up a so-called upload preset. Click on the settings icon, then upload. Scroll down to the preset section and click add upload preset. We are going to name it timelapse_pi and specify that images be uploaded into the folder timelapse_pi. Now click on Upload Manipulations. We're going to resize our image to 640 by 480 pixels on upload, but there's a wealth of transformations you can apply here, including intelligent face detection algorithms, applying gravity, etc. Click Save, that's it. We're going to follow the Nerves installation guidelines. Just note that depending on your operating system, you will need some additional packages, usually to be installed via your package manager. Please refer to the docs for that. Nerves recommends installing the Elixir language and the Erlang OTP runtime via the ESDF version manager, so we need to install that beforehand. Next, we need to add the Elixir and Erlang plugins to ESDF to have access to the packages. Let's create a new Nerves project with mix_nerves.new, timelapse_picam_nerves, -- init gadget. We confirm that we'd like to fetch the project dependencies as well. Next, we need to set the mix_target environment variable to RPI0, so our firmware will be cross-compiled to the correct device. Note that probably you're going to have to use a different command here since I'm not using bash, but the fish shell. You likely want to run export mix target equals RPI0 instead. Let's look at the mix.exs file and add 3 more dependencies. The first is PyCam itself. The second is HTTPoison, a lightweight HTTP client we're going to use to communicate with Cloudinary. Third and last is nerves_time, which is necessary to sync the Nerves system clock with an NTP server. Alright, let's run mix_deps.get again to fetch the updated dependencies list. Let's see what we have to do in terms of configuration. We head over to config/config.exs and skim through what has been bootstrapped for us. At the bottom we find an import statement pointing to target.exs, which we enter. The key section is important because it sets up the public SSH keys of your host system to be used to SSH into the nerves device later. If you don't know what that is or how to create one, GitHub has some excellent guides on this. In the nerves init gadget section, we go straight to configuring our local Wi-Fi instead of the USB port. Change the IF name to WLAN0 and address method to DHCP. Then edit the MDNS domain to something more telling. Timelapse_pychem_nerves.local. Next, we are going to actually configure the Wi-Fi settings. I'm going to copy-paste in some code here to set the key management either to the one provided by an environment variable or WPA-PS key as the default. Then we configure the network adapter WLAN0 and the SSID PS key, which are going to be set from outside via environment variables and the key management. Last but not least, we need some app-specific configuration. We need a Cloudinary base URL, Cloudinary API key, and a Cloudinary secret, which will all be obtained from Cloudinary and set as environment variables too. Before we can actually start hacking, we need to set those environment variables. First, the Wi-Fi network credentials. Then we define the base URL for all interactions with the Cloudinary API. Next, we head over to Cloudinary and grab our API key and secret. Do you know this image? Now we're going to draw the rest of the OL. Let's create a file for our image uploader first. Next, we'll create some module attributes to hold our constants. First, tags and upload preset, we name both timelapse_py like we specified before. Then we fetch key and secret from the application environment like this. Now let's create our take picture and upload function. This is pretty straightforward. You could split it up into different functions, but I'll leave that to future refactorings. We start by taking a picture with pychem.nextFrame and apply base64 encoding. We then construct the data URI by specifying that it's of type image/PNG and that it's base64 encoded and concatenated with the actual image data. Because we are going to submit it as a form data post request, we need to URL encode it too. Let's think of some public ID to reference our image later. I call it timelapse_py followed by a timestamp. That function doesn't exist yet. We have to write it ourselves later. It's just a placeholder for now. And then Cloudinary expects us to supply a signature in a certain specific format. Here too, I write a call to make signature function that doesn't exist yet, but we'll deal with that afterwards. Alright, let's next construct the actual URL we are going to send our request to. We take the base_URL we specified as an environment variable before, followed by /image/upload. That's Cloudinary's endpoint for uploading image data. Finally, we get to concatenating the actual request body consisting of the file, where we supply the file data URI from above, the API key, a public ID, the tags, the timestamp, the upload preset, and the signature. When that is all said and done, we finally send off our request by a call to httpoison.post, supplying URL, body, and a set of headers represented as tuples. Here we only specify the content type. And finally some options. For some reason, this particular request only worked when explicitly setting the TLS version to 1.2. Okay, that was the hard part. Now let's look at the help functions. For one, we need that timestamp. That's pretty easy. We fetch the UTC now and convert it to a Unix timestamp with to_Unix. For the signature required by Cloudinary, we first need to construct a string out of some params that are key value pairs. We do this by a call to enum.mapJoin. The mapper function interpolates key and value into a string joined by an equal sign. The whole list is then joined together with the ampersand character. Afterwards, we take the string, append the secret, hash this with the SHA algorithm, apply base 16 encoding, and downcase it. This might seem contrived, but it's the exact data structure that Cloudinary API expects. Okay, now we need to actually complete the call to make signature. Cloudinary expects us to supply all parameters that are also present in the body, except for file and API key. So here we go. There's another twist though. Those params have to be passed in alphabetical order, otherwise it won't work. Alright, that was almost it. As a last step, we only have to make sure the application supervisor starts the picam.camera process. We trigger the firmware generation with mix firmware, insert a micro SD card, and then run mix_firmware.burn. We only have to do this the first time though, as Nerve supports hot reloading of the code via SSH. Yay! Now we plug the micro SD card into the Pi 0, start it up and connect to it via SSH. And here's what's really neat. We're instantly greeted by an IEX console, where we can just go about and try our code in a REPL. Call Timelapse picam_nerves.image uploader.takepicture and upload, and observe that we got a 200 response back, which means everything should have worked. We head over to the Cloudinary media library, see that timelapse_pi folder was created, and voila, an image of yours truly. How cool is that? Let's conclude this video. At this point, we have already covered a lot of ground. We'll leave the actual generation of the time lapse to the second part of this tutorial.